Hi, chemists. I'm gonna go through the 1130 isotopes PhET assignment. We won't do every problem together, but I will explain what's going on. So the first thing you want to do, your notability, is to click on this PhET link. Okay, and it is going to bring you here, and it will have this highlighted. So you want to click the symbol and then click it again. Make sure you check stable, unstable. Okay, so what we're going to do here, we've built atoms on this before, but now we're going to talk about a thing called isotopes. Okay, so the first one says use a simulation to build 3 different isotopes of hydrogen. So same element, hydrogen. Keep in mind that atoms are neutral, so charged particles should balance, and complete the table below. Okay, so when you start out, right, you're gonna have these symbols. So figure out what that isotope notation means. We want to build these 3 isotopes. So the first one is going to be, we want to build hydrogen. So we add 1 proton and it becomes hydrogen, but we don't want a positively charged +1 charged ion. We want a neutral atom. So we need to add a negative blue electron, and now it's a neutral atom. Okay, so if we look here at our symbol notation, we have a 1 on the left top and a 1 on the bottom left. So that matches here. We have a 1 and a 1. So we have made this isotope. So now we're going to fill in this information. So our element name is hydrogen. That's what we were making. Our symbol for hydrogen is an H. Now we need number of protons, positive, number of neutrons, neutral, and number of electrons, negative. So we go here, we have 1 proton, no neutrons, and 1 electron. So 1 proton, 0 neutrons, and 1 electron. Mass, okay, mass here, we are going to find this symbol here is like a balance. Okay, so this is our mass number, this one in the top left. So our mass number here is 1. Okay, and is this stable or unstable? This one looks stable to me. Okay, so we are going to put stable. All right, so what we're going to do next, let me pull these, split this a little so we can see what's going on. All right, so the next one we want to build, the only difference here is that this 1 in the top left became a 2. Okay, so let's take a look and see if we can get that number to be a 2. So let's add some things and see what changes. So if I add a proton, it did change to a 2, but then it also became an ion positively charged, +1 there, and a 2 at the bottom. And this one has a 1 at the bottom, so it's not the proton. Let's try an electron. All that changed was the charge went to a -1. We didn't change these numbers at all when we added an electron. So our last option is a neutron. So if I add a neutron in there, look at that one more time, add a neutron, this number becomes a 2. We add a neutron and this becomes a 2. Our mass becomes a 2. So we have now this 2, 1, 2, 1. We have this isotope of hydrogen. So let's think about, what did we change when we did that? What did we adjust? So we had 1 proton. We still have 1 proton. We had 0 neutrons in this first one, and now we have 1 neutron. We had 1 electron in the last one, and we have just 1 electron here. So the only thing we changed was the amount of neutrons. Okay, our mass changed to 2, and this is still stable. Okay, so let's take a look. Let's change this last one. We're still going to make hydrogen. The symbol's still going to be H. And we have to make sure it still has 1 proton, because otherwise it will become a different element, right? If we add a proton, it becomes helium. We don't want helium. We want hydrogen. Okay, so now our neutrons, we want to get this mass number up to 3. We got our first one, 1, mass number up to 2 by adding a neutron. So let's try that again. We'll add a neutron, and we change our mass number to 3. Okay, so there are now 2 neutrons. There's still 1 electron, and our mass number is 3. But what else changed is that this became unstable. Okay? So this is the idea here of isotopes, right? So let's take a look at 2 through 4. What do the numbers in isotope notation represent? So the 3 up here, is our mass number. And that changed when we added a neutron. Right? If we take one away, that goes down to 2. We put 1 in, it goes up to 3. There's another thing that can change our mass number, and that is the amount of protons, right? So if we have 2 protons and 2 neutrons, we have a total of 4. We have 1 proton and 2 neutrons, we have a total of 3. So the numbers here, right? I can't write in this one, but the numbers here, the top number, the mass number, is the amount of protons plus neutrons. Amount of protons plus neutrons. Okay, and then this number at the bottom is a 1. This is color coded on here, so it's a 1 in red, orange, and this one's red too. So that means that number at the bottom tells us how many protons we have. This is just protons. This number up here is protons plus neutrons. So which particle makes all 3 of these the same element? That's a little review. That would be protons. Right? Protons tell us what element we have, the amount of protons. What particle makes all 3 of these isotopes different from the others? Okay, what did we change between all these? These all stayed 1, these all stayed 1, but we changed the number of neutrons. Okay, we changed the number of neutrons. All right. Next, you are going to build carbon. Okay, 3 different carbon isotopes. Okay, so we'll do this first one together. Okay, let's clear this, reset, make sure we have stable, unstable checked. So in order to get to carbon, we need to know how many protons carbon has. That's the number up here on the periodic table, so 6 is what we need to get to. So we're going to put 6 protons in here. 2. Okay, helium, now it's lithium, now it's beryllium, boron, and we made it to carbon. We have 6 protons. It's very unstable and it's positively charged. We would like it to be neutral. So let's balance out our positive charge. We have 6 plus 1 charges, so we need 6 minus 1. Each electron is minus 1. 1, 2, 3, 4. Notice our charge changing. 5, 6. Now it's neutral. It's right in the middle. It's balanced. However, it's quite unstable. So this says, use a simulation to build 3 carbon atoms with different masses. Make 2 with stable nuclei. That's not stable. And 1 with an unstable nucleus. Let's make a stable one. So we're going to add neutrons until we get to stable. 1, 2, 3, 4, 5, 6 made this stable. Okay, so we have a neutral atom, that's what we want, of carbon. It's stable. Okay, so that's one of the 2 we need to make that are stable. So we have 1, 2, 3, 4, 5, 6 protons, 6 neutrons, and 6 electrons. Okay, so in your chart, add that in. This is carbon with 6 protons, 6 neutrons, 6 electrons. Our mass is 12 because remember our mass units are the protons plus the neutrons. So 6 plus 6, we get 12. This is stable. And then you're going to you're going to draw in C, the C for carbon, and a 12 in the top left and a 6 in the bottom left. Okay, so I'm going to let you complete this part. Okay, you're going to make 2 more isotopes of carbon. So you don't want to change the protons, right? You want to change neutrons. So you can take away a neutron, you can add a neutron, whatever you want to do, but you need to make one more that's stable, right? That would equal the two that are stable, and then one with an unstable nucleus. And you're going to add in this information here. Okay? So what's coming next is 6, 7, and 8. Okay? Which two particles change the mass of the element? So we discussed when you adjust the protons, it changes our mass. When you adjust the neutrons, it also changes our mass. So protons and neutrons. What about electrons? If I move an electron out, did it change this 12, this mass at all? It did not. And the reason is because electrons are so tiny. They're so tiny that we don't even count them when we're adding up the mass of an atom. That's how tiny they are. They look way bigger in this model. They're really, compared to these protons and neutrons, we wouldn't even be able to see it on the page here if we actually made it how small it is in comparison. They're very tiny. So protons and neutrons change the mass. Which two particles change the charge of an atom? That would be our protons, positively charged in red, changing our neutrality, right? This electron also changes our charge. The neutrons, do they change the charge at all? Nope, still 0. Changes the mass, but it does not change the charge. So protons and electrons. Then it says, what do we call an atom when the charge is not neutral? Hint, make an atom not neutral in the PhET and see what words neutral atom change to when you add or remove electron. So let's remove an electron and see what happens to this neutral atom title. Okay, change this word. It says plus ion, plus ion. We took away a negative charge, gave plus ion. What if we add a negative charge? It's a negative ion. Okay, so what atom changes to is this word ion, which is ion. You add or remove electrons. All right, then in class, I explained that you need to finish 9 through 11 on your own. Okay, if you are stuck, I have office hours on Friday at 9 o'clock. Come to those, and I will be going through 9 through 11 on Friday. Otherwise, you can work on it on your own. There's 2 videos, one video for the definition here of an isotope, and then one video for calculating the average atomic mass of carbon atoms. There's a video example of a different problem, but it will help you figure that out. Okay, so that is 11:30, the isotope PhET. Please email if you have any questions.